Hello, my name is Eric Avalos, and today I will be talking about the light reaction. And this is my diagram for it. So, the first arrow that goes down is to chloroplast, and that's the reason I chose chloroplast is because that's what brings in the light from to the sun. It goes to the chloroplast, and that's what grabs the light. And then inside the chloroplast has the chlorophyll, and that's what uses the light for energy. So in the next arrow I have here, it says that enters dipole space into photosystem 2. And basically what I'm trying to say is that the photon light enters through the dipole space, and then it enters through the photon system 2. And then when it's in the photon system 2, it goes through the reaction center chlorophyll A. And when it goes through that, it excites the photon, and then when it excites it is transferred then onto a mobile carrier, and this one's called plastocutene, yeah. And then after that photon leaves, the photosystem then converts water into oxygen, and that the reason it does that is to produce the hydrogen ions, to have them in the, if I'm correct, I think it's the lumen. Yes, in the lumen, to have them in the lumen so they can help with the other reactions. And also the byproduct for this one is basically is oxygen. So then we need humans need oxygen. So that byproduct helps all humans and all animals that need oxygen. So then you move on to the next arrow, and then the next arrow says the electron is transferred to cytochrome B6F complex. And this one is just like I know this one uses that photon. So when that mobile carrier goes to this this complex, when it uses it so it can move basically the protons into the thiol space, so then it can be used later on for ATP synthase. So when you move on to this next one, here, I explained it right here. Yeah, the photon passes through the cytochrome, the complex, and to the thiol space. And yeah, it's it's actually the stroma. Then from there, the electron is carried through another mobile carrier. Then this one is called plasmacytin. And then that mobile carrier transfers it to the photosystem 1. And then from there, it also kind of excites it, and then brings it down to to another mobile carrier. Oh yeah, sorry, I'm getting lost. Okay, to another mobile carrier called ferredoxin. And this ferredoxin basically this is what is needed to how do you say to use it for the NADP reductase, which basically is you do the reaction of NADP plus a photon, and that gives NADPH. And then this final one is the ATP synthase, which I was talking about earlier, where the protons in the thiol space come back through the ATP synthase, and that forms the ATP. So that's all I have for the light reactions. Thank you.